filters, no audio filters. Compressor, okay, ratio, output gain, let's increase by 1 dB. Close, and yes, the compressor should work a bit better. Let me listen to the audio if it sounds okay. Yeah, so we are back. Now it's the end of the day, and I wanted to work on something and to how is it called? When you just lack of work. I don't want to think anymore. Work is finished for today, and I want to do something easy. And something easy will be this desoldering gun, and the grabber is dead again. So I have to restart OBS. See you in a few minutes. Now we are back, and I hope that the grabber works. I have no idea why it disconnected. I hope it won't do it all the time. So this is my desoldering gun. Let me have a quick introduction about desoldering. Normally when you desolder, there are plenty of solutions on how you would want to desolder. The easiest solution, well, the first one you would think about is having a desoldering pump. You just use the soldering iron, solder on one side, press on the desoldering pump, and when you press on it, it just sucks the solder. This is very useful for through-hole components, and I still use it for large surfaces. So for through-hole component, this is what you use. For surface mount component, it's not a strict rule, but where is it? For here. For surface mount component, you use desoldering wick or desolder bread, solder wick or desoldering bread, and it's just through capillarity it sucks off the thing. You can also use it for a through-hole component, but you will use a lot of wick because there's a lot of solder. So generally what you could do is use this to get lots of solder away, particularly in through-hole. Use this to clean the pads and remove the remaining part. And solder wick comes in a lot of different qualities. This one is bad quality. It doesn't have any flux in it, so you just have to put flux before you use it, else it works really badly. Some solder wick or desoldering bread has some flux embedded. This one doesn't, so be aware. And else just add some flux, you can clean it afterwards. That's the first solution. The pain point on this one, so there is that you need two hands, one to solder, desolder, because you heat up using the soldering tip, and then you absorb. But this is if you have two hands. What if you don't have two hands, or if you have a lot of devices you have to desolder? Then there are other tricks, and I need to find them. This one is one of them in my stock. Here. This is a combination between a soldering iron, so it heats up, and a desoldering gun, which is embedded. And when you have plenty of devices, well, it is not somehow not temperature controlled, it is fixed, but for desoldering it's not that important that you have the right temperature for desoldering, because you're only there for a quick time. You want to remove the component and you control the time how it is on by just looking at it, and as long as it is hot enough for the solder to be sucked by the pump, then it's good. So even something like that with no temperature control, it's fine, it works for desoldering. So this is the next step after the desoldering pump. So the soldering iron integrated in the desoldering pump, or desoldering pump integrated in soldering iron. And then comes the next step, at least still for through-hole components, this one. This is a larger desoldering iron. Idea is the same. You have a soldering iron or something that heats up. You have the hole in the front, but instead of having to push the lever, every time you want to have the vacuum, here we have a gigantic pump, which is just a solenoid actually. And when you press on this button here, the solenoid creates a vacuum to suck the solder. That's the next step. And but this is really, it doesn't work. It worked at the beginning, now it doesn't work that well. And you only have like one action sucking in, so it doesn't suck a lot of things. There's only a limited capacity. Sometimes it doesn't suck enough, and then you have to be on the button, unpress the button so it removes the solder which it sucks away from someone else, so something else, go back to the pad, suck again, go back to your sponge or to your bin, and then remove it, or removed on press, so the pump so the pump reinitializes, and then so on and so on. So this is better because you don't have to press manually on the vacuum pump. It's automatic, but you still have to move a lot, particularly if you have lots of solder. So next step for desoldering, again for through components, is the desoldering gun. And here we just have again soldering iron, which heats up with a hole in the front. And when you press on it, there is a vacuum pump here. So I think this is for the power, this is for the vacuum. And not yet completely back, although, yeah, we are back. I don't know what happened, the complete, my now it's not the fault of the USB anymore, it's the fault of the video capture driver. The AMD GPU just driver, which is for my graphic cards on my laptop, just completely died. It did recover, but it froze for some time. So let me reiterate. This, the desoldering gun, this heats up, you put it here, and then the vacuum is constant and it puts all the solder in this reservoir. And I didn't have a desoldering gun for a very long time. What I did is just use the thing by hand, or when you do a lot of surface mount devices, you use a hot air gun, or this is just blowing hot air, and you could blow hot air on all the pads and then use tweezers to remove the pad from the other side. So this can also be used for desoldering, no issues at all. The problem is that this doesn't remove the solder, so for holes, through hole parts, you still need a way to remove the solder. Either you use soldering wick, or you are back to the desoldering pump. This is why for through-hole components with lots of solder, a desoldering gun is quite good. And I got it very late in my, I think this is probably 1 or 2 years old, and it's good. I mean, I found it very expensive in the beginning for what it does. It's just desoldering. Why shouldn't I use a desoldering pump and pay a lot of money for that? But it's when you have lots of board to desolder or to rework, it's really a pleasure. So I recommend having desoldering gun if you use a lot of electronics. For just a couple of them, it's okay to do it by hand. As soon as you have hundreds of boards, or just 10 of boards, this is worth the time you spend on it. The problem on this one is that it is very loud, and we will test it. I need to get mains cable to enable it. You will not hear it exactly, but I can show you using a meter. Here now I have cable for power. Let me plug it in. Now I need a sound meter. This is my sound meter. What kind of battery does it use? AAA. Rechargeable AAA. 3 batteries. 1, 2, 3. 3 AAA. Up. And if I enable it, you see that here 70 decibel is the somehow between 70 and 80 is the somehow the normal speaking range, and this is decibel A. A is just how the decibels are weighted over the frequency range, and it corresponds more to the hearing. Decibels is the decibel range, so every time it increases by 3 decibel, it is twice as loud. And how you measure it is you put it 1 meter from the target. Here it's too far away for me. My bench is not big enough for picking 1 meter, so you can still see it. So we will not put it 1 meter away, but just here. And if I enable it, power is on here, power will be silent, and you will see how loud it is. So you see, it's 10 decibels. It's not as easy the calculation, but just that makes 10 decibels. And when it is running all the time in the background is a kind of a pain. And I don't know why it does that. It's a bit annoying. I want it to be silent when it doesn't do anything. And the thing what I found weird is that it's not to cool off this device, because the fan is in the box, in this box. So I don't know what it does. And the purpose of today will be, well, we will have a look at inside what it does, who makes the noise, and we will try to make it a bit more silent. And here we start with today's task. And up. Now you can see a bit more because this is a huge device. Up. We will use our mat to, let me get rid of this because this takes place, and I've presented my desoldering devices. You don't need to see them anymore. Up. Okay. Where is the pen to mark? I know it is somewhere in here. There it is. So, top cover. This will be the screws for the top cover. Up. And it is unplugged right now, so no issues there. I won't have a shock. At least until I've opened it and replugged it. So, what it is? I bought the cheapest one I could find. I don't know. Here it says CCOM ZD 919. It is fine. I'm sure there are better ones. This is really the cheapest I could find, and it works okay. So if you look for other devices, you might find something else. I didn't test any other desoldering gun, so I wouldn't be able to say if it's good or not. Compared to the other one, it does the job. And it's better than I did by hand. So this is side. This is not the right screwdriver for the job, for the task. Where's my huge screwdriver? There it is. It was in the wrong box. This is the appropriate screwdriver. Do we have to remove? No, let's remove the stand. I have no idea what the stand is for. Here, normally you have a sponge. You have to glue it here, and the sponge doesn't hold well, so you clean the tip of this. And I actually don't clean the tip because I want it to have all the time some. It sucks everything in, and sometimes I even have to add solder so the tip doesn't get so used because it's high temperature and it's little solder. So I only use that. I don't know why they provided the stand on the bottom. Maybe it's just a standard thing from other soldering irons. Yeah, never used this sponge and it doesn't hold up in it. So this is bad design, or I don't know what it is used for. See, it hasn't been used once. No, it's been never used. It's been burned because it wasn't wet and I didn't put it correctly in, but I've never used it. the vacuum of the desoldering gun. Seriously, did OBS, did this USB device die again? Why did it? I have no idea why it does die all the time. Let me get a USB cable and can connect it directly to the computer and not through the hub. Maybe it will make it a bit more stable. Yeah. So we are back and the stream, I hope that the USB is a bit more stable. I connected directly to the computer and it's not passing through one USB hub. So let's have a look at the inside. First, yes, the sides are not directly connected to ground. I would expect this to be connected to ground. It isn't directly. It's bad because I don't think that this is conductive. I think this metal isn't conductive. Let's try it out. No, this metal isn't conductive, and also the insides are barely conductive. Maybe the screws, they have some kind of anti-slip things inside, so that might bite inside and have contact on the metal and then have contact on this metal, but I don't think it's a very good fit and that it holds very well on, that it has a very good contact. I should measure it somehow. So I don't know if this is really grounded, and I would like, well, if this part is really well connected to ground, I would have expected some connection to ground, like somewhere here or somewhere else. Maybe it's enough, but doesn't look very good. And this is the device. And power supply. This is, I don't know what this is. So the input goes here, it goes to the power supply. Here we have the control electronics. This is just for the buttons. This, yeah, control electronics with microcontroller. What are you using as a microcontroller? It is, I've never seen it, On-Bright Q839A. I don't know this microcontroller. There's a Holtec on the side here. There's a Holtec microcontroller. Holtec is very famous for the LCD, its LCD driver. So this is probably just to drive the LCD, and the main one is the microcontroller. There's a 24C02. This is EEPROM. So this is probably to remember what temperature we last set. And then, yeah, I don't know what this microcontroller is. On-Bright. Is it CB or C? CB39A. Let's have a look. On-Bright CB398. On-Bright CB39A. On-Bright Electronics. Yep, it exists. And that's the logo. Let me show you. We are here. On-Bright High Performance Analog Multi-Mix IC. That's the device. CB. Maybe somewhere. But yeah, On-Bright exists. Never heard of them. At least there is a logo I have to add to my collections of logo. Let's remove that. And let's get back to our device. Here's the clunky on-off switch, which switches off mains. This one. I like it. I have a lot of devices which really switch on and off mains and don't have a soft start, like this oscilloscope here. This Rigol DS 2000 something, they all only have soft start, and I've modded mine and I've added a rocker switch on the back so I can actually shut it down completely. So yeah, the pump, the power supply, the electronics, just a board for the buttons. Yes, it is only for the buttons. This is for the soldering. Ah, wait. And I still don't know what this box is. There's a box on the back. This is the fan. I think this is the fan which is really loud. We will see. Here the pump somehow has... Does it work twice? It has 2 inputs and 2 outputs. One output is just the air, so the input of the desoldering gun goes to one side, then probably back this side, and then goes back in here and then goes out, and this way it has double action and even more oomph for desoldering, maybe. I will not test because I don't really care about it. This has no markings, and this power supply has no markings. I don't know what it provides. It's probably something like 12 volts. I don't know what this is. So there are only two signals going there. No, there are more than 2 signals. There are 2 signals coming in and 2 signals coming out. This is the driver for the pump. Okay, this is power in. I see that this comes from the power supply, so this is power in. And then it has these, oh, there are 4 wires actually. 2 wires are for the fan. And so it drives the, oh, does it? Yes, it drives the fan. And then there are 2 additional wires. These 2, one for the motor. There's one going to the motor and one going to the soldering iron. So I have no idea what it is. But I think the culprit is this one. So let's switch it back on. And let's test to see if this fan is just so noisy. Here my screwdriver. The power supply makes a bit of noise, but not too loud. Now I don't want to... Oh, yes, this is very noisy. I don't know why you would want something that noisy. Okay, the pump is probably getting warm. The motor doesn't have any feedback, no. So I think it only provides power through these wires, and it doesn't read if it is turning or not. So if I switch on, it's a lot more silent. There's still noise. Oh, I should put this in the holder so it doesn't get too warm. I think the noise is just coming from the power supply once it heats up. So let it heat up completely. So there's a high-pitched noise. I think this high-pitched noise is not audible, or is less audible when there's the cover. Let's wait until it heats up. Oh, let me just go down with the temperature so it heats up fast. Okay, 200 degrees. Once it reaches, is this second noise source gone? From the switch mode power supply. But this fan is really noisy. This we need to change absolutely. This is a 12-volt fan. So there's how to change. By that, I don't know what the airflow for this fan is. Also, it seems to. but maybe it's an overkill. I mean, this is a cheap device. I don't think they've imagined anything too fancy, or did any fancy calculation. Just used. Let's have a look. If I have a 12-volt fan which makes less noise, I do have a bag of fans, AC filter, a box of fans. I just need to find it. Too many projects. Fans. Here they are. And if we don't have something which is a bit more silent, we will make it more silent. I think one of the reasons is probably because it is the grill. Here, you see these holes? They are just punched in the thing and they don't have any... There is no pattern really which allows the air to pass through it in a fine way. There's huge metal in between, and I think all the air trying to get through all these small holes make it loud. So we could, for example, just make the holes bigger or space this fan a bit more on this side so the air has a bit more chance to find a way to go through the holes. We could use also another of these fans, like this one for example, and I'm sure this one is a bit more silent. Let's check it. Well, actually this switch is mains off, so I could leave this mains power on, but let's not. And let's open this device and let's open this fan and test the fan just by itself. I'm too lazy to get... Oh, can I? Oh, maybe I do have the right tool to open it. Not here. Do I have it here? Might be. Yes. Oh, it's even too loose. It's probably... Oh, it is 5.5 millimeters. Or actually, and this is just to hold it, unscrew. Make it more silent. First, we'll check if I can use another fan, or we'll just check the fan how loud it is outside of the box. Let's test how loud it is inside of the box. Let's have our measurement point, this one placed always at the same distance, so we can make some comparisons. Okay, the camera sees it's here. Let's make it here our reference. So I'll shut up and we will see how loud it is. "56 decibels. We want to go something like 50 decibels. I don't know if it makes any sense, so I'm just telling the measure this way. It might make no sense at all. It will still be annoying. Anything less loud would be better. There was no warranty sticker, but I don't care. I won't send this away anytime soon. So, do we want to make the hole on the back larger? Let's try not to. Also, so this fan, how does it turn? Sometimes you have markings. Here I have no markings at all. So I will add to need a marking to know which direction it turns, where the air flows. You could also see it sometimes looking at the propeller or the blades, fan blades. I prefer to mark it. Okay, it turns this way and the air goes so it doesn't, oh, okay, so I was a bit wrong. It doesn't blow the air through the grill, it sucks it from the grill because the air goes in this way. So it's really to blow on the motor, and I think the motor gets warm. And this is very good because if this is the case, I know what to do. So up, let's unplug that. Is this a connector? I hope it is. Let me have a look. Yes, it is. Perfect. Having access to the connector will be a pain. So these are fan screws. I have plenty of fans. Currently on the stream, absolutely no one. But at least here on my mat, I have 4 fans. This is the motor controller. I don't know how we'll call it this way. Motor controller. Cont. 1, 2, and this way I can even have a look at what is inside. So this is the fan connection. What is inside this box? What does this do? So it seems to be the motor driver, but why have it on separate box? And why not on the same PCB? And I don't know if I can, if this is, I can open it. Seems to be like an impossible task. Come on. Okay, one side is open. Let's open the other side. Come on. I've never seen such a stupid tab. Okay, this tab is a pain. And power's off, yes, power's off. Okay. Okay. This is nothing but just some ballast resistors. Is one for the fan? Let's check. This is input voltage. One side goes directly through the plus of the fan and through the plus probably of the motor, and the other side goes to, oh, they're in series. See, the minus, no, the plus actually. Oh, this is weird. Did they mix plus and minus on the motor? The wires? Because here it is black, and the black is going to the red of this pin. So either this is not ground black or this is not ground black. Let's measure it. These are 12 volts. So on the motor we've seen that this is 12 volts, so this is not 230 volts. I'm fine touching it. I don't think, and here we have a switch mode power supply, so this is not AC coupled. Let's measure who is wrong and who is right. Oh, I did. The fan is, it is loud, but not that loud. So is this right? What? 18 volts? This is a 12 volt motor. And here. So this is right. So the minus here is really ground and the plus is red. So it means that this minus here, so what is the input? 18 volts input. But the black is the plus and not the minus. We have 18 volts. This is just a 12 volt DC. This is really driving it hard. Who thought about this design? Is it normal to have 18 volt? Is this an 18 volt motor? And it always goes through this 5 watt resistor. I don't know why. For the pump, for the motor, it makes a bit of sense. 5 watt, it's just 1 ohm. Maybe to remove the motor noise induction. I don't know. We will keep it. I'm sure if they have a box and things like that, there was a reason for that to work correctly. But is it expected to have 18 volts output? That's a huge difference. Is there a marking somewhere to tell me what the output should be? And this is just to hold the motor in the bracket, this kind of cylinder, and to damp it a bit. Here is a diode. I think this is, how is it called, a flyback diode. So when the motor switches off, the power goes through this flyback diode and not through the circuit. So this should be enough protection. I don't know why in motors you would put a resistor, but it is there. And we know that, yeah, it makes a lot of racket because they are using a 12 volt fan and they're providing 18 volts on it. Yeah, not good design. I don't know if the 18 volts should be there or if it's just... let's have a look at this motor. What is written on it? Well, motors, it's hard to define the operating voltage because the higher the voltage, the faster it goes. 2019 0725. Okay, that doesn't tell us anything about the motor. I'm not looking at the motor, I'm looking at the bracket. Can I get the motor out? No. The problem is if I try, no, I will not try to lower the lower the voltage because I'm sure that the pump works better with 18 volts here. Now the problem is I need to find, I have plenty of motors. Let's try to find one which actually operates at 18 or 24 volts. That's 12. We can also put a 12 volts motor, but yeah, now I know what is so noisy. Maybe I have something else. 24 volts. Okay, I have a 24 volt motor and the holes don't match, but I don't care because I can make new holes. This is a 24 volt motor, is it? Yeah, DC 24 volts. So having it at 18 volts should make it turn fine, and we can use this. I have no idea why I would else use a 24 volt. This is 12 volts, 12 volts, yeah, 12, I think I only have 12 or 5 volts. This is probably 5 volts. This is from a, how's it called, GPU. What do I have here? 12 volts motor. Here. There's 12 volt again. These are too small, they won't do the job. And this has no marking, so it's probably 5 volts. This is a radial fan or an axial fan, so it won't do. The only 24 volt motor is this one. And sure, it's not the right one, but Let's check if it works. So 24 volts, we want 24 volt output. Do we have the right pins? Yes, we do. You should also be able to see the output of the power supply on this on the dashboard. And let's have it turn 24 volts. And I think here again, I don't know how it turns and the direction of the propeller. So let's set 24 volts just to test 24 volts. Does it work? Do you see that I'm setting 24 volts? No, this stupid script died again. Yep, the script died. Up, let's start it. 24 volts here. Let's limit to, I don't know, how much does it take? 90 milliamps, so let's limit it to 200 milliamp. Oh, does make some noise. It is super powerful. Let's switch on. You see, it does make some racket. But this is at 24 volts. We will operate it at 18 volts. This is 18 volts. And you see we have already 6 dB less. It is still very loud and it is still plenty efficient. But what I will do is a second trick. So we will use this motor instead of the 12 volt motor. So we will need to change the pin out. I will put, wait, how does it, here, you see, here there are some, I'm not sure if it's visible on the camera. Here there's an arrow pointing, turning, showing that it turns this way. Let me draw it again. Let's switch it off. So it tells it this way and the air goes this way. So we will have to mount it like that. What I will do is also, so I will have screws here. I will kind of put some cushion or something around the side here so it dampens a bit the vibrations. I'll probably put some rubber. I don't know yet. Or just not having standing yet. So there will be new holes just for you. Is there enough space just for you? With the box, oh no. There's not enough space with the box. Damn it. Without the box there's enough space, but we shouldn't do that. Oh, maybe there is. So what is the input, what is the output? This is probably the back. Here we see the holes. So this was the back, and I will mount. Can I put the fan in next to it? No, I can't. It doesn't fit. So my 24 volt motor does not fit. That's a shame. I had a good solution. I could have it a bit further away. What else can we do? There are a couple of things we can do. Instead of feeding it the 18 volts, we can have DC. Can have power supply. Yeah, I can't. I won't be able to fit it in here. So yeah, we can't use the 24 volt motor. That's gone. Now let's test the 12 volt fans, and let's measure the difference between the 12 volt fans. I have plenty of 12 volt fans. Let's have some which are silent and the same format. Same format, not same format. What is this? Not same format, so I only have this one as same format. Let's measure the noise at 12 from both. No, it's not. 12 volts, 120. Oh, this seems a lot more sound. Fifty. Yeah, this one is a bit more noisy. So we will keep this fan, we'll power it at 12 volts, but we will not only do that. What we will do is we will probably power it at, can we cheat? What voltages? What I want to do is operate it at a much lower voltage when the motor is not high and only switch on when the motor is high. And for that we have some things like thermocouples. I think it is in power protection. I do have a box. Power protection. Here, my box with plenty of power devices, and yes, that's the thing I was looking for. These things here. It's an overkill, but I have them here and they work. How this works, I think it is normally open, and once it reaches 50 degrees Celsius, so you can have a different things, once it reaches 50 degrees Celsius it closes, and this will just simply switch on the power. To this box, and I think, yeah, 50 degrees is fine. The motor probably can hold up with 50 degrees. So we will put it here, we will put it in line, and it will switch on the 12 volts motor. We will operate it. It is normally closed now. Yes, this is, so the 100 kilo is just my fingers. They seem to be humid. Yes, this is normally open. Yeah, normally open. I need to buy more then. And they are rated, actually, you can see on the top, they are rated for 250 volts, 5 amps. We will have 12 volts, something like 100 milliamp, so they're plenty fine. We will have it directly connected here. We don't have to use the shrink tube. We can directly, oh, it is magnetic a bit. We can have it connected directly there, and so this will switch on the 12 volts. Now what we want to do is the fan to also turn while it is not at 50 degrees, but turn really silent. So we will measure what really silent is in here, so we will know which voltage it uses. So what is really silent? This is too loud, even in a box. The thing is dead again. Now we're at 9 volts. 9 volts, it is acceptable. I will still try to lower it. 8 volts, oh yeah. 8 volts, it's not annoying anymore. And it would still cool a tiny bit of this, the motor pump. So we will have it at 8 volts. So we need to switch down from 12 volts to 8 volts, and it uses 40 milliamps. So we have 40 milliamps. We want to drop 8 volts, 4. We want to drop 4 volts, 40 milliamps. This is 120 watts, milliwatts, 120 milliwatts. So we can use a 1/4 watt resistor. And we just have to measure how much we can. So we will try with, instead of doing the calculation, we could do the calculation, but we could do it another way around. So let's do both of them. Do the calculation and do it anyway. So we have 40 milliamps and we have 4 volts. What we want to drop. So, hey, come on, why? This USB hub is annoying me now. Why did the USB hub die? So yeah, we don't see the cat moving anymore. We didn't see any picture for a long time. Let me start again. Up. Okay, I've restarted OBS. I restarted the hub. I hope the hub now holds a tiny bit longer. So we have the resistance is the voltage divided by the amps. This is 4 volts divided by 0.040, and that's simply 100, right? So we need 100 ohm. We would need 100 ohm to go down. Sure, it will burn energy, and how much would it burn? Yeah, 120 milliamps, milliwatts. That's okay. Burning 120 milliwatts is okay. So what we could do instead of 100, because I don't know if I have 100, I do have plenty of through-hole resistors. I do have a box of through-hole resistors already here. What values do I have here? 330, 470, no. I want something like 220. That would be nice to have a 220 resistor. Then I would put 2 in parallel, and I think they are 1/4 watt resistor. Oh, no, that's a good question. What is the color code? Does the color code mean 1/4 watt? So we have 100, but I think the 100 is a bit too. So are these 1/4 watt or the 8 watt here? I have a box with plenty of resistors. I don't know. So they're blue. Does blue mean 8 watt? A 1/4 watt, or does it mean 8 watt? 1/4 watt would be nice. Let me check in my inventory. So my inventory, you don't see it. That's okay. Passives, resistor, through hole. They are all
quarter watt resistor. So they're plenty sufficient. I will still use 2 quarter watt resistors and put them in parallel. And I will use 200. Do I have 200? I have 100 ohm, so this is perfect because this is kind of what we need. 100 ohm, 150, 220. Perfect. So I will use 220 ohms resistors. Come on, go out of this box. 330 quarter watt, yeah. So we'll use 2 of them, meaning we have half a watt. This is plenty enough of margin. We'll have them in parallel, and with 12 volts, normally still in parallel, we should have a very silent power supply. And this is what we will try. So plus is connected here. I need, normally I should here have some headers. They're not here anymore. No, oh, sorry for the camera. I just bumped in the camera. I don't have headers anymore. I get long headers here. It's my long header parts box, and I need a long header, but just one. Oh, I think I put them in my breadboard box. This is why they're not here anymore. One header goes here. Up. This is one side. On the other side we will put crocodile. Let's put it red. Let's use the red one. Red, and normally if we put red here. So now it still turns, but it doesn't draw anything. Let's put it to 12 volts. Volts. Let's put it in the box. Oh yeah, this here is more noisy than putting it a tiny bit away. So I will put some spacer. And now it's not annoying, and it's still blowing air inside. So I think we'll keep it this way. And if we can still change, so we could probably put 330, 2 of them in parallel, so we have 150 ohm resistance. Oh, they are getting warm though. But not very warm, so it's still touchable, and they're rated for that. So, oh, these resistors here. So, by default, it will always go through this resistor and through the motor. And once it gets too warm and it reaches 50 degrees, we shunt this resistor, so we will put it this way. We shunt the resistor and the complete 12, this way, and the complete 12 volts will go through the motor. And this will cool down, well, until it is less than 50 degrees. And this will make it more silent. Didn't I mark it on? Yeah, oh, it is marked. I will put some, yeah, are these M3 screws for the motor, for the fan? I'll put some spacers, that's for sure. And now we just need to put everything in the cable, which is here. And since we will use the same motor, we can just reuse the cable and put it in line. And this is long enough to go. So this should be put on the other side of the motor. This way we are sure that it's not only this temperature sensor, which is at 50 degrees, but the complete motor. And then we will solder it. Yep. So let's get some
cable tie. Is this long enough? No, that's not long enough. Let's get a longer cable tie. This is probably long enough. Also not. Okay. Oh, these were shorter? Or these were the same length? Ah, these are the same length. Okay. So what do I have which is a tiny bit longer but not too long? Because I have some which are really long. They're probably too long. Well, let's use them. Up. What I could also add is thermal grease. So it makes good contact. But I should put it this. Now the problem is if I put it this way, the cables are in the way. And I can't have a good contact. So I could put some thermal grease. Thermal compound. Oh no, don't just put thermal compound. It's metal to metal. I hope it's good enough. Ah, let's put some thermal compound. I have plenty of it. And we don't, this motor is probably withstanding 50 degrees without any problems. And even if the contact is not good, it will probably work at 60 degrees or 70 degrees. So the compound is not necessary. But I have plenty of it and we want to do it a bit correctly. So let's put a bit of this silicon compound on it. This is thermal joint compound, silicon type. I bought this 10 years ago and I still didn't use it completely. This never gets used, so I have plenty of it. We could also actually use tape. No. Let's strap it on. Okay, we have compound everywhere now. I did make a mess. I will have to clean it up. I want it to press correctly. It's really a mess now. So we'll put the tie on the other side. Now it's firmly on it. And it's holding well. Up. Let's clean the mess. Let's switch on our soldering iron because we want to use it. Soldering iron. Up. The USB hub died again. Yes, the USB hub died again. I have no idea why it died. Both USB died. Oh, I hate that. I have absolutely no idea what makes my USB hubs die. Well, I'll have to use another one. So, sorry, I need some water for the sponge. Up. These are the resistor. We need to put it across here, so we soldered this together. Solder wire. There's a thing I forgot.
I need to add something in between. Okay, so this is one side. Let's solder so the other side. So now this thermal resistor, or this temperature protection, bypasses the resistors if we reach 50 degrees. And cut the leads. What we also need to do is now transform the 18 volts into 12 volts to operate the thing as it does. So we have the voltage regulators and my box of voltage regulator, and I'm sure I have a buck converter. I have a large one like this, but this is for 3 amps. I want a smaller one. Step down here, adjustable. These ones. This is not adjustable. Step up, down. This is probably step up and down. Oh, what is this device? Oh, LCD driver. LCD driver. PVM control. LED driver. Okay. Here we have step up, down. This is step up, down. This is step down. Okay, these are step down converters. Apparently they do up to 3 amps. I don't think so. They are adjustable, and here we have 12 volts. So we could actually try to solder the 12 volt pin and check if this works. I don't want to solder. I hope enable is on by default. So 12 volts. This is in, this is ground, this is VO plus, it's probably V out. Let's check if this voltage regulator works. So we have ground here, plus here, and let's switch off this. Let's put it to 18 volts. It is normally able to handle up to 24 volts. Let's put 15 just to test if it works. No, that's the outputs. That's the input. And this, oh, this is ground, sorry. Input plus, that's ground. Okay, it doesn't draw anything. Does it output anything? Let's check with the multimeter. The output should be this one, and the ground is this one. 12 volt output, 2 volt output. Oh, I just made a short. Yeah, 2 volt output, maybe because there's no load. No idea how these things work. How do I test it? Maybe because it is not enabled. How is the enable pin? Is it enable high? Or is it enable low? What is this module? Let me check. So 12 volt is selected correctly, enable. I don't want to solder pins on it because I want to solder directly the wires. How do I do that? And I want to test this device, so you go away. I don't need it for now. Yep. Let's put it somewhere out of the way. up, up. Oh, this is out of the way. Okay. So this device, this has a potentiometer because it is. I can zoom now that we have a smaller work. So this device, you can select on the bottom which voltage output you want, or you can adjust it. Or you can solder the adjust, and then you use the 3-pot. I've selected 12 volt output, so it should work with 12 volt output. Maybe we do have to put a load on it. Let's add a resistor to 20. And let's test if it works with resistor. So this is V plus, this is V probably output, this is ground. Switch this off, connect ground, connect input. The ground is also connected to this lead, so we'll connect it. Oh, I'm not seeing anything. The ground is connected here. The multimeter is connected now to plus. Hang in there. Okay, now we have a load. A light. Okay, I have no idea how this thing works. It draws 4 milliamp. What did they write on the box? I just wrote step down. Adjustable 3 amp. Okay. Oh, we all have minimum 100 millivolts, milliwatts. I do have another step down. They're very similar though. Ah, this is another adjustable step down. I want the step down to work. I need to check. Or is it a step up? No, if it's a step up, we would see. Let's try. If now I switch down below 12 and we have an output above 12, no, we don't. Maybe we do. It is swinging. Let's connect the fan. Maybe it works with the fan. So the fan needs I need some cables. Here a cable box. Here we have some of these power cables. We'll use this. So I think these are XH connectors. Since we need to be in the middle, we need male and female plug and receptacle. For now, let's do it this way. So ground is connected to ground, and then plus. Up connected to the lead here and to the lead here. Now it doesn't output anything. Let's go above 12 volts. And this thing doesn't do anything. So maybe the enable pin must be tied to high or low. Let's short the enable pin, or let's use a resistor. Oh, let's use a cable to short enable high or low. think it would make more sense to short it low for it to enable. So this is the enable pin. Let's try on low. This is low. Okay, this is completely switched off. Let's put the voltage a bit higher. So yeah, you should see on the motor. Somewhere. Here. If I put it on low, it's completely off. If I leave it floating, it's probably pulled up and it wants an output, but the output is not the 12 volt, it's a 2 volt output. I don't know why it's only 2 volts, although the setting is set to 12 volts. How? We can still use the, let's switch this off and let's try the adjust. Potentiometer adjust. Maybe this works better. We need a tiny screwdriver. This, maybe not this one, but a trimming screwdriver. So we don't need to switch. See, this can go away. We don't need to enable it actively because it is enabled by default. Now let's switch it on. And what if I turn this potentiometer? And USB dial again, no. 12 volts. So, yeah, I have no idea how the voltage selection works. With the adjustable, it is adjustable. So we will keep it in the adjustable mode and use the trim pot. It is now set to 12 volts. And this is fine. And yeah, this is blowing enough to cool down. And this is the rated fan. Okay, so we have that. Now we need to put that, we need this back. No, we don't need this back yet. No, we do. This will be inline of the motor, right? So we need to cut the cable inline, as the name says. Let's split the cable. So where do we split the cable? So it goes this way. This will go somewhere here. So it doesn't need to be super far away. It will go this way. Here. Somewhere along here. Up. So we separate the cable. Okay, it doesn't work. My thing is, I need to use a cutter or a knife. Here. Oh, a lot easier. This is split. Now we use a wire stripper. Let me move the camera a tiny bit. And my side. Yes. Wire stripper. One side. The other side. Let's tin the cables. Solder is here. cable 1, cable 2. Tins we will put here. We want them to have breathing in the air so they can cool a bit down. We'll still add a tiny bit of shrink tube, just so it looks nice at the solder joints. Red is maybe, let's use this size shrink tube. One, two. Is my microphone sometimes clacking? No, let's move it a tiny bit. Well, I'll switch on my microphone so I don't hear it so often.
Okay, my microphone is a bit further away, so I'm maybe a bit more silent. Okay, someone is shouting outside. Not happy about something. I don't know what. Oops. Shrink tube here. Shrink tube. Let's do it one after the other. And we don't care which one is which one. There is no polarity in this thing. On the other side. That's the other side. And we can actually test it. So that's the other side. This, we still want it to be in the air to somehow cool a tiny bit. It doesn't have to cool a lot, but it will produce some heat. And then we can test the motor. So, I need the output of these lines. Cables. Let's combine. This is plus. And minus is. This is minus. Okay. Now let's set to 12 volts. The fan should already be turning. I just need to find the fan. And I'm hearing something here, but it's not very loud. The fan is turning, but it is not turning a lot. This is because by default it goes through these. Yeah, they're heating up, but really not a lot. And they will be in the way. And now let's try to heat up this thing, and normally at some point it will make clack. It's reaching 50 degrees, and this should turn faster and draw probably more energy, more amps. So yep, instead of 30 it's drawing 50 milliamps. And I hear that this is louder, so this works. And if it cools down, how can I show you? No, you can actually see the power usage. No, you can't, because the thing is dead again. And now it's switched off. is not stable. And now it switches off. Now it lowers down. So this is good. This is the first part. We have a 2-speed regulation. I'm sure there are driver. There are probably motor drivers which do that, but here we did it this way. I need to check if there are motor drivers doing speed regulation with test. And now we need to solder this in line. And if we could, yes, we can have the output connector directly here. That's nice. What is plus? What is minus? This way. This is minus, so it needs to be soldered that way. Minus, minus, yes. So we'll solder it directly on the board. Just solder one pin. Will be involved for the motor, and the motor will perform well. And we have voltage input. How will I do it this way? I'll put it on the other side. See what I'm doing. Moving the arm a tiny bit. Up. Now you can better see what I'm doing. And the ground pin is up. Seems okay. And I will put some tube over. Do I have some shrink tube which fits? It doesn't short too much. Yes, this does. So I will cut this one somewhere here. I did hit the microphone again. Sorry for that. Up. Oh, I do have to put a limiter on my microphone. Every time there's a the click. Okay, I have to put a limiter. The click noises are caught by the microphone very loud. Very loudly. Oh, shrink tube. Or just add some compression. The really strong compression on the upside. Okay. The voltage regulator is on the shrink tube. And now we can test the device as a whole. The output is, so voltage regulator here. That's the outputs. It goes into the voltage regulator, then the output of the voltage regulator. I don't know where I will put this. I can have it hanging inside. Yeah, there's no thing which could short, although here maybe a tiny bit. Would be unlucky. I'll still put it, hold it somewhere. And let's try it out. Up, power. Switch on the power. Something burned. The plastic burns. Why does it? Oh. And this is really warm. Oh. Did I short something here? Isn't it putting 12 volt, 18 volt out? Ah! This resistor is super warm. Something happened. There was even smoke. This capacitor, this resistor is super warm. This resistor is super warm. This is also super warm. So I did probably something wrong. Did I switch plus and minus? I did switch plus and minus. So there was a short. On these pins, plus and minus are the wrong way around. This is why there was a short and lots of dumping. I didn't pay attention to that. Let's switch this around and test if it works. This might be dead. I think the power supply here is fine. Well, we'll try. I made a mistake. Let's see if I caught it in time. Since it was not stopping but continuing, I think the power supply is fine. I don't know if the transformer is fine. Wrong tool. It's also not the right tool. Might be better. No, it's not. I did have a tiny screwdriver. Let's disconnect this. Here. Let's try with this tiny screwdriver. Push it down. Retention clip. I did. Make a poke again on the microphone. I really have to put the limits in. It smells a bit burnt. Okay, this doesn't work. Let's try with the needle again. is this one. This is plus. This is minus. Right? Let's check. Plus, minus. Now it's the right side. Now it works. So, where's the fan? Here's the fan. Let's put it on top of here. We can watch it. With power, it's better. Now it works. There's still this. Where's the soldering gun? Wait. Soldering gun. Let's put it here. This way I have a view on you. Soldering gun is here. So yeah, we still have this annoying little sound in the beginning when this heats up. Now we can actually try already the desoldering pump. It might be a bit loud. Maybe it's a bit loud. But I want to test if the fan turns more once it is warm. How to switch here? This is very loud. I'll be a bit further away. It's loud. Let me just switch off the microphone until I test it. So the pump doesn't get warm at all. It doesn't heat up. I thought it was to cool the pump, but the pump doesn't heat up. So, well, it will, in case it heats up above 50, we still have the protection, but I think it will never. I mean, I've pressed for it for 30 seconds. I never saw desolder more than 30 seconds. I think we're fine. We can put everything back together and test it again. Up. Let's switch it off. Off. Let's turn this off. Let's put this back on. Let's clicked. I don't know it yet. Soldering iron, I can switch it off and we can put the first, oh, this has not enough magnetism. Let's put it in the magnetizer. screw. It won't hold too often, but that's good enough for now. Okay, that's one. And now on the other, I said I wanted to put this shrink tube. Let's put the shrink tube back in the box. I wanted to put probably not a dampener, but at least what kind of screw is this? Is this M3? I hope it is M3 because M3 I have enough of these thingies, nuts, and you could even use nylon. M3 screws. Let's test it with M3. Here's a small box with M3. Here's some nuts. I hope this is M3. So I can use some nuts to put some space between this and that. This, we can put it down. The fan should be this way. So, oh, I could even use inserts, which are a bit longer. Maybe they're a bit more stable. I could plunge inserts here. And this way I can just hold on inserts. Oh, it does plunge completely. So no, I can't use inserts. It goes through the holes. I've lost it. Yeah, nope, no inserts. So nuts. I have to use 4 nuts. And I need to order M3 nuts. Oh, I can nylon nuts better because they would dampen it better, maybe. I have nylon screws for normally non-conductive, but I could use the nuts from there. 1, 2, 3, 4. This holds well. So we need to put this. The nylon will make a tiny bit of split. I have something longer. It would be nice to have. Yep. Can I repurpose one of these things? Let me show you what I mean. Damn it. Here. This nylon nut is a tiny bit small. What I would like to do is, if possible, reuse one of these spaces so we can go completely, if we could go completely through it, because they're a bit longer. How much space do I have? Do I have that much space? No. And it's smaller. So no, I don't have enough space for one of these things. Well, nylon is some nylon inside. I hope this dampens a tiny bit. One. screw. I need somehow to tighten them. Up. Let's use on one side plier and on the other side screwdriver. Okay, I don't want to strip them, so don't force too much on it. Okay, two more. Not this one. First. Okay. Plier, screwdriver, and next. Get it hold. Next we fix this. I was surprised that the motor doesn't heat up. Maybe it heats under load, but there was a thing in the middle, so there was a tiny bit of load. Well, if it heats up too much, it will. We have the safety. I think it is not mandatory, and we could actually just have the motor turning at 8 volts all the time instead of putting this protection. But I didn't test it. This way I'm safe. And actually, yeah, we could even lower the voltage of the fan if we still find that it is too high, because it is not fixed now. We're still using the trim pot. Sure, the trim pot, which is in here. Sure, we need to cut here to turn it, but we could make it even more silent now. Up this and this. So the spacer, I think, will help for the air to flow better. The nuts will help for the air to flow better inside, so it goes this way, and at the same time it will try to dampen it. I hope it will dampen it a tiny bit. Why do you have to put this? Can't short. Could short a tiny bit. I'll put some glue, some hot glue here, so it's not able to short. Anyway. Heat up the hot glue gun, which takes 10 minutes. Time enough to test everything. So let's put this here. The fan should fit, or even the fit of the fan is tight. Up, let's put screws. Tighten the screws using a proper screwdriver. Up, one, a should probably add some dampers here on the metal. I think it's fine. Two. Up. Yeah, maybe the metal screws which are now putting a lot of force are directly putting the vibration through to the screw, and not every it's too loud. We can still even lower the voltage now. Okay, this is mounted. There's something weird here that this side is higher. I think let's try it out. Oh, is the hot glue already ready? No, it's just the first. Great. Let's try it before we put the hot glue. This is those things we need to protect. And with hot glue we can actually put it somewhere. We can actually glue it somewhere. That's cool. So do on. You switch on. It's louder than the fan. Yeah. The transformer heating up the desoldering gun is louder than the fan. Decibels. Ah, you don't see. Sorry. Yeah. So it. Then there will be more air. So we are on this side. Yeah, the transformer for the heating up the soldering iron on the desoldering gun is louder than the fan. Super happy with it. Now, let's unplug this. Let's put some hot glue. First, the contacts to put some strain relief and protect the contacts. Up. Next, we need to figure a place where to hide everything. This should be, the resistors should be in the somewhere where the fan can blow on it. And this, actually we will hide it just under the fan, so we know what it is for. So we'll just add a blob of glue on top of here and stick it to the case. Up. The cables. Yep. The resistors are on the way of the fan, so it flows perfectly. It creates also some turbulence on the motor, which is a good thing. So let's close this device. Can you actually put it the other way around? Do I want it the other way around? No, I don't want it the other way around. Not this time anymore. At some point I wanted to. Now I don't need to. Up, up. Yep. So side screws are these ones. To put a limiter, I hear the pop. I think this microphone, which is another microphone, has a tendency of really getting the strong pops and amplifying them. I need to limit that in the compressor. This is okay. I need you. I need this. Let's put screws on top. One. Okay, that's good enough. Let's put just the second one on the other side. Ooh. Now the screws on this side. And one screw. Two screws. The hot glue gun. Now the last two screws on the top cover. So let's tighten the screws on the side. 1, 2, 3. Now we can put the screws on top. And the last one. At least the case is robust, there's nothing to say. It is 1mm of metal. It is very robust. Up. All the screws are there. Let's measure the conductivity between, so let's go to ohm, between earth pin and one screw, for example. Yeah, you see, I'm touching the screw and the earth pin, and we don't have any earth here. So the chassis is not grounded, or not grounded correctly. Here, do we have something? Yeah, here it works. On the side, it works. Here it doesn't work. This one works. This one doesn't. Maybe I need to tighten up. So, but the chassis is grounded. Else it wouldn't work here. So the chassis is grounded. It's not perfect, but it is grounded. Now let's test the desoldering gun again. So let's put this back where it belongs to. Somewhere here. I'm not seeing it. You are seeing it. Okay. Switch on the power. Oh yeah. Let's switch this on. This is on, and so you're also seeing it. Yeah, 40 dBA. I can hear the fan, but really the fan is more silent than the transformer. The hissing of the transformer is louder than the fan is. So I'm perfectly fine with it, and I think it works well enough. And I need to charge the batteries on for this device. But yeah, with that, mission accomplished. We we made the desolder gun a lot more quiet, really a lot more quiet. And I'm happy with it, and I can put it back on. And the hack for today is finished, and I can close the day. So, enjoy the rest of the day, and see you another time for the next time.